There's no STP. How do you know? The builder has put a tank and he called it STP. There's a small overflow on the top. That goes a drain. That is next to the Vartur Lake. The drain goes to Vartur Lake.
So you're one of the polluters.
One of the polluters.
Your gated community is one of the polluters.
Most people don't understand sewage. They don't care about sewage. You only ask for...
But there's a lake. I mean, I don't understand how people don't understand that. They say they want lake view and they're destroying our lakes.
If something can kill chemicals, that organism is a beast.
We would not want another Wuhan sort of virus outside.
First of all, ECOSTP or any nature-based STP works, right? The fundamentally works. It's not oxymoron. Water can be recycled. We have clients who use the water for over 1,000 times. Whatever the dinosaurs pieces what we're drinking now, it's the same thing.
Now, if you're living in one of these new age apartment complexes, you would have come across what is known as a sewage treatment plant or an STP. Now, it's not something that you would like to go there and see. They consume a lot of energy, there's a stench around it, and they use a lot of chemicals. But what if I tell you that there is a better way, a more eco way of treating sewage? And to discuss more about that, we have with us the founder of ECOSTP, Mr. Tharun Kumar. Thank you so much for being here on Let's Talk Water.
Thank you, Nolan. Happy to be here.
Let's begin. But before I talk about what you're doing, how you have revolutionized treating sewage, sewage treatment is a critical issue, not just in Bengaluru, but across the nation today. What do you have to say about that?
Yeah, obviously, it's a huge issue. One of the biggest issues humanity is facing is sewage. If you look at a population, 8.2 billion people in the world, 1.5 billion is in India. Right, and we are it's a big number.
1.5 crore people live in Bangalore itself.
Yeah, I'm talking 1.5 billion.
Yeah.
Right. So when we all flush multiple times a day, it all goes in, and if you don't treat it, it gets piled up. You have to keep on doing it, and that's where the challenge is. Treating needs a lot of power, chemicals, and that's where the challenge is. So if you look at India's population, 1.5 billion, the government can only do 300 to 400 million. That's all they can do. That's all we have, power, chemicals. That's it. Rest has to be treated somehow. So that's where the nature-based systems like ECOSTP comes in, decentralization comes in. That's how this comes in. If you look at the Bangalore case, like you mentioned Bangalore, I know you know better, 11 million or 12 million something is the population now,
15,
right?
1.5 crores,
oh,
yes.
Man. Yeah. So
it was 1.2 crores, I remember, with 10 lakh floating population.
Yeah.
But now it's 1.5, they say, plus another 10 more lakh floating population. So you can imagine the amount of sewage.
So the government clearly said long time back, guys, I can only do a small way. When they said around 4 million residents is all they can do. That's it. Plus that, you have to do it. I mean, it's up to you.
But
right?
Tharun, isn't it the job of the government to actually clean sewage? We're paying taxes.
I know. We're paying taxes. In fact, we're
paying a lot of taxes.
Absolutely. But they think, guys, I can do only this much, right? And beyond that, you have to do your own. And there's a used jargon called polluter. You're the polluter. Polluter pays. So in this building, for example, you have to run your own STP. Now the problem is, it's okay, I can, as a tax-paying legal citizen, that's my law, I do this STP, but power, chemicals, operators, I give up after 3 months, 6 months, and I let out to the drain nearby, and the drain goes to the water bodies. So that's a cycle which you're trying to do.
No, it's good you mentioned this, because I wanted to ask you, what happens when you finally let untreated sewage into urban drains? What really happens? We have seen what's happening over here. And one of the big reasons for the Bellandur, the Vartur Lake, many years ago, I'm sure you would have remembered, it was on fire, it was fraud,
Right.
is because of untreated sewage and also effluents from industries.
Absolutely. I mean, that's a sad case, like Bangalore specifically, because everything goes to water bodies, all the muck.
Yeah, we're destroying all our lakes.
But if you look at Chennai, we have the Kuam River, it all goes to sea. Delhi has got Yamuna, and
we have seen what happened.
Yeah, Mumbai has got the Arabian Sea, right? So, but unfortunately, we don't have anything. We have already had this lake, so it all goes there. But the fundamental problem is the issue is a tech issue. It's a technology problem. That's where I'll talk about more.
It's a technology.
Right? It's a tech issue. It's not a government issue. Government can't do anything much. The tech is broken, right? So we have to keep adding chemicals, keep adding power, blow air. Is very tricky, technically complex machinery. I'll explain more.
Now, are you saying this because you have a background in tech that you're saying it's a tech issue?
Yeah, maybe. Yeah. Right.
Okay.
Yeah.
So tell me, what are the limitations of a traditional STP? And before we talk about ECOSTP,
Yeah.
why are traditional STPs insufficient in today's times?
Right. So let me talk about how I got in. Then I'll explain this
Go
STP.
ahead.
You know, really. So I was not an STP person. I'm not a water engineer. I was an electronics engineer, right? So be surprised. So I was in IT. I was in IT security for 20 plus years.
IT security to STP.
Yeah. Cyber security was my specialization. I worked in multiple companies. Last I was in Aadhaar. From Aadhaar only I moved in here. How it happened was an accident. So people say, I'm in deep shit for last 10 plus years. Literally, I'm in. That's the last 10 years. So let me explain the accident well, how it happened. So I was a secretary of the RWA association. I live in a gated community in Bangalore. One day there was a big noise saying STP is overflow. So we all came running and we searched. There's no STP. How do you know? The builders put a tank and he called it STP, right? And yeah, and there's a small overflow on the top that goes a drain. And that drain goes, so that is what it is, right? So, okay, that's what we have. And that's what hit us. You spoke about the Varthur Lake. That is next to the Varthur Lake. The drain goes to Varthur Lake, the one you covered a lot, Nolan. The Varthur Lake, remember?
So you're one of the polluters.
One of the polluters.
Your gated community is one of the polluters.
So we used to always blame the government for.
You're sure it's safe to be telling me this?
Of course. All of us are. The Varthur Lake is all the sewage that's coming in.
Yeah.
Why do you think it's burned? Like, remember you covered last time. It burned for 14 hours.
The last time I remember when I went there, I was in India today. Then I remember standing over there when it was frothing. Lives after lives that we were doing because Delhi wanted us to do that. And my throat was burning,
Absolutely.
My chest was burning, and I remember my eyes were burning, and that froth, which people said snow, the moment it would fall on your skin, it's not white, there would be this black soup.
Yeah, I know, yeah.
It was terrible.
It was terrible. So I vividly remember the lake burning. It's a 500-acre lake burning for 14 hours. They got the army to douse it. 5,000 Jawans came in, they're bitten by snakes. It was a mess. Right, so we thought, man, we are part of this. We are part of the problem, right? Easy to blame the government, but so immediately our moral compass woke up. Okay, let's put a STP in place and let's quietly do it. Let's not tell anyone that. It's a big shame, man. Why should, like you said, I'm also part of the problem. Let's quickly, and I can't close the outlet because then muck will come here. So let it go to the lake. Let's put up STP. So we formed a STP committee, and that's how I got into this STP thing to learn more of STP.
Okay.
Right. So then what happened was we formed a committee. Okay, let's, like all IT guys, let's choose a vendor and then let's get it done with this and quietly, quickly. So we called one vendor and that's he sells a tool called MBBR.
MBBR.
Moving Bed Bioreactor. I know they all do fancy names. So he comes in to sell, all the water flushed down will go to a tank. So nice tank. But you have to blow air from the bottom. So that's a technical issue. You have to blow air. Like a fish tank you're blowing air. And it blow air for 16 hours at least. Or 20 hours. It
consumes a lot of energy.
And Bangalore, there's no power cuts. It's hardly everywhere. There's
don't have power most of the time.
Most of the time, right? How do you do this? So my colleague said, don't worry, we'll put a solar. But then the vendor says, no sir, you need grid power because these are running 20 HP, 30 HP motors. So we need to have that means you have a genset. Then I asked him, why do we need to blow air? Because it's a bacteria working on it. So it's known as aerobic bacteria. Okay. So that's the key thing, aerobic. ECOSTP works on anaerobic. Now aerobic is where that needs air, you need to blow air. So common sense, I need to breathe, I need to air. Okay, it's 16 hours. Then the vendor says, don't worry sir, if power is off a few hours, I'll manage it. I said, how will you manage it? Will you blow air or what? But that's how the system is. Then that's adding to agony. He said he has to take from another tank. He built one more tank. I'll send you some pictures, I'll explain this. You take the tank sewage from there and put it here. You have to add fresh bacteria every 1.5 hours, right? That's another adding to the complexity.
So you need another person over there just to
do this. So I suppose why can't you do this only this way? I know I will only give one tank, take it or leave it. No sir, you're IT guy. This is a RAS process. What is RAS? Reverse activated sludge. I kept quiet. So
MBBR is different?
No, yeah. So all same. Okay. So MBBR is a name, but this is a RAS process. You add the bacteria. So the clean water comes, like you said, we put operators. Water comes to the top, the clean water. Not clean, but it will be relatively clean water.
Got it. That can be used for gardening purpose, so maybe
not yet. Not yet. Yeah.
Okay.
You have to suck it out. And they don't say suck it, they say decanting. They take it to a tertiary treatment system.
Okay.
It's basically a dome of sand. So you put a dome with sand and you push the water to the sand.
Okay.
You filter it. So you're not treating, you're only pushing through the sand. And then the water comes out. But so that when you push it out, you have the muck in the remain, the top.
Yes.
That has to be thrown away. That, don't worry, sir, I'll take care of it. Okay, where will you take care of it? That's the thing. Then the clean water goes to another dome called charcoal filter. Right? And then the charcoal, active charcoal filter, another dome. And then you do a disinfection. And then you have clean water. So you have multiple components, 5-6 components, and it works well. But anything goes wrong, your water is bad. And so I said, nice, this won't work out for us, not sustainable. Sorry. We tried another vendor. So another person came in. This was going a couple of weeks, and we are getting frustrated because we want to quickly get it done before the
sewage is still going into the lake.
Yeah,
Okay.
yeah, right. Okay. We call a new guy he sells something called SBR.
MBBR, SBR.
Sequential batch reactor. So SBR and MBBR constitute to 99% of the STP market. That's all the same, no difference. So SBR guy came. This is expensive. He came with, I think, the jacket and all, a little more professional guy. So the difference is he's got 2 tanks. So all the muck comes into one tank. He blows air for 10 hours, switches off, and he do the next tank for 10 hours. So shift 1, shift 2. I said, why didn't you call it shift? Why are you calling sequential batch reactor? Right. So that and whatever. So 10 hours here, 10 hours here, but the same issue. No change, same tech. Then I said, do you need to add bacteria again? No, not bacteria. They add MLSS sludge. I said, why you want to do that? No, that's MLSS, sir. You don't understand. What MLSS? Multi-liquor suspended solid, right? That's a jargon. So early guy said RAS, he said MLSS. It's the same thing. He adding bacteria. I said, guys, man, make it simple. So you're adding bacteria there. Then the same charcoal filter, sand filter, disinfection is exactly the same thing. No change.
So basically, he had some 5-6 chambers. This fellow had 2.
2 minutes. It's fundamentally the same
it's
thing.
The same thing, different names.
And there's no change at all. And that's just the situation we are in. So yeah,
these were the type of STPs that are prevalent across.
Then we did a Google search. Right, what is this? That'll be some other way out. We thought we are con because we are IT fellows and these guys are in corners. This is how it is everywhere. It started in 1914 when the engineers, Lockett and Edward in UK, they started this activated sludge process. The blowing air business and the adding bacteria. The same thing now. No change. 100+ years.
So many years.
So many years. Incremental innovation happened. Okay, some small changes. Recently we met a Japanese blower. It's got less noise, better way of blowing things. But the same
concept remains the same.
Same mousetrap, some incremental innovation. I said, guys, man, this is, and we came from IT world. Everything changes every every month. This 100+ years, we're shocked, curious what it is, and then that's how I really got curious on how it is, and that's how we got into this. But this is a tech now. No change. Everywhere the same thing. Blowing air is the same thing. It works. As long as you have operators, chemical, power, it works very well. You get clean water out, but there's a cost to it.
I'm itching to ask you why you're sitting with that cow there. But go ahead.
Yeah. So we said, okay, we can't afford this. We can't run this. We need to have some other way. How did nature solve this problem? So simple, curious question. How did nature solve this? So somebody said, okay, septic tanks used to treat waste. Okay, what is septic tank? So let's check out septic tank. So we checked out septic tank. Okay, there's some, but it won't treat well. It's more a tank. Then we used our, good old IT principles, that 5 analysis, root cause, why. So they said, okay, you do a proper septic tank using Darcy's law. It's a calculation how to make a septic tank. It treats well. But then we did ask more 5 We found it's actually anaerobic bacteria in the septic tank which makes the work, which the key person, hero, who actually treats anaerobic bacteria.
Not the aerobic bacteria.
Not aerobic bacteria.
Okay.
Right? Anaerobic bacteria doesn't need power, chemicals, nothing. No operators. It was like, aha, anaerobic bacteria. What is this? We studied a little more. What is it? Then we found anaerobic bacteria is more prevalent in a cow stomach. A cow stomach, that's where the cow come in. So cow stomach is a anaerobic bacteria factory, so to speak. The 4 chambers, rumen, reticulum, omasum, all anaerobic bacteria.
Learned in school, yes.
Yeah, and it can even digest cellulose. Right? Then I said, okay, then it looks great. Why don't you use that? Why are you using aerobic? Right? So that's where I left my company. I thought I'll jump in full-time to this. I joined a waste management company full-time to learn this because I had to unlearn everything and learn something new. But it's so magnificent. When you learn more about anaerobic bacteria, it's like an addiction. I know you should Google out anaerobic bacteria. It's not one bacteria. It's a set of bacteria, 4 sets. Hydrolysis, acidogenic, acetogenic and methanogenic, 4 stages, and they all work in unison, right? And when you study how do they, one bacteria knows that other work is over. It's like a relay race. All work in unison, and it's like we keep some honey, sugar comes, Nolan. Same thing, right? But that we know some science, like ants go all over the place. There's a pheromone trails. That's how they find the honey. But here, inside the water, how does it know that?
Tharun, actually, I wanted to ask you, how did you find or identified this space ripe for innovation? But I think I have the answer. It's the anaerobic bacteria.
Yeah, that was the bacteria, and then we tried to make. So we had some idea. We made some blocks. Then we approached our association and said, guys, let me make one STP for you. It's not STP, I'm trying my level best. It costs money because all civil work. But if you don't do this, your plan B is power-based SBR and MBBR, always there. But give me a chance, be door by door, we'll knock them, we raise money. And it's like eating your own dog food or what I call it, right? you did for them, we deployed one basic STP, very basic one. And results were pretty good. So we got it working, the basic element.
No chemicals.
No chemical, no power, right?
But the water at the end
was good, but it's not that great. But it is much better. I won't say it's perfect, but it was conformed to the norms of the central pollution control norms. It was, yeah.
Without using anything?
Without using anything. Then I knew, wow, this is great. Then I said, guys, let me start my own company, focus full time on this, let's do a little more. That's how ECOSTP as a company was formed.
Wow. So the entire concept of biomimicry is
started from there, but then once we formed the company, we got multiple incubators. I went to Biomimicry Institute based in the US. So
you actually went there?
Montana. Yeah, we also got a grant from them, and wow. they flew us down multiple times. And they are the world's leading experts on mimicking nature. How do you learn from nature? All the learnings we got from the science. There's a science behind it, right? So we got the mimic from there. So Biomimicry, we got a lot of institute. We got a lot of insights. Then we got also incubated in UK, the LIF, the leader. We got conferred as a leader in innovation by Royal Academy of Engineering. So Royal Academy of Engineering, we got that. So we did they also got a lot of earnings. There we learned a lot of gravitational science. It's all gravity. So when you say zero power, how does it go? You don't know about gravity.
So basically this was incremental learning.
Yeah, incremental.
It's a process.
Yeah, a process. But there are some blocks where you make a leap. Like gravity was a big one, because gravity, if you crack gravity is free. It's the Earth's force, right? How do you harness gravity? So how much water can you push? And there's a lot of science behind the
angle and everything.
Angle. So how much water you could put too much, the water will not treat. So a lot of insights came from the gravity.
So why don't you walk us through what happens from flush to finish? How it works?
Right. So when whatever it happened, when whatever flush down, your grey water, black water, washing machine waste, all the waste. Everything. We don't say only this and that.
So there's no differentiation between grey water, black water.
Black water, everything. So some people say, don't give me this water. I only take. I can't. As a customer, I can't say that I have to give everything to you. I can't say you should not say that. Give me only this water, that water. So all the water comes in and to the. So we call the first stage one, wherein all the comes in, and we put a inoculum to make it to degrade the contaminants. So we have the stage 1, stage 2, stage 3, mimicking the cow stomach. So how the cow stomach works, similar structure which we've done, but it's a series of tanks. You can just say it's a series of septic tanks stacked together. There are 12 chambers, one after one, in 3 stages. So from one stage, it'll go to a second stage by gravity, and when it fills up, it'll go to the next third stage. And slowly it gets treated, and there's an anaerobic digestion in a very detailed space. And by stage 3, you get not good quality water, but very good, not good, but at least visually clean water.
Okay.
Then you run through a wetland. Wetland is a good old concept.
Correct.
Right. So
true.
The beauty of wetland is, remember earlier when I spoke about MBR and SBR, we are only sieving. We are filtering
with sand.
With sand and all. Here I'm treating. The plants take out. The plants suck out all the impurities. So
that's the last stage.
The last stage we call tertiary treatment. Okay. And the disinfection also happens throughout. So we don't need any disinfection. But if you want to use the water for flushing or a car wash, you need to put a disinfectant in the last.
Okay.
Only then. Okay. Otherwise, is taking care. So wetland goes in, and then you have clean water comes out.
So
no power,
after
no
the wetland, that water can be used for gardening.
Yeah, gardening straight. But if you want to use for flushing or car wash, you have to add a disinfectant. See, it's already there. It's a disinfectant is built in. That's the beauty of natural systems. Disinfectant in other normal systems, SBR and MBBR, disinfectant is an add-on unit, a chlorination, ozonization. Here is built in, but That's nature doesn't understand this separate business, right? So
it's all there.
It's all there. So let me take a minute on this. There's a treatment and disinfection. Both are a bit different. You can just put a chlorine on a piece of muck, then becomes all bacteria will die, but it's not treated. It's only disinfected.
Okay, there's a difference.
Yeah, there's a difference, right? So
disinfection and
treatment, right? So in our case, we do both together, treatment and disinfection both, and there's no byproducts like the other one. So normal STPs have byproducts.
So where are the byproducts then over here? What happens?
So what I didn't tell you about that. SBR and MBBR, because the complexity goes high. You take the muck, only half of the muck is treated, exactly 50%. And some say I'll do 60%. Rest it comes out as sludge. And this Nolan is so crazy, and they don't use gloves, it's normal operators. Sludge comes in, they have to scrap the sludge and using a tool called filter press. Very technical name again. And you press the whole thing into cake. And then you dry it out, right? And then so stage 1, 2, 3. In our case, it's a completely bacteria breaks it down. So we call digestate. It's not sludge. Sludge is what you get from normal STP. This is what you call the output of a bacteria called digestate. It's a good fertilizer. Many customers use fertilizer.
You can use that as
it's a fertilizer.
fertilizer.
In Europe it's not a brown gold in Europe because it's nature's original. The other one we call it sludge. It's not fertilizer. It's just a muck compressed together. Toxic stuff.
So what comes out from your system can be used as a fertilizer. Not in traditional STP.
Not in traditional STP, right? Now, there also, traditional STP, you have so much muck coming in, that you sell it as fertilizer, but it's not true. Similarly, I'm talking about basic STP. Now, when you come to the filters, that charcoal filter, sand filter, again, when you do backwash, again, water comes out. None of them are treated. Look at our RO systems, right? If you took RO system, half the water is wasted.
Yes, a lot of water.
Water is wasted because that's a residue, right? Because that's how nature doesn't understand. Nature doesn't work in that principle. Nature treats. So ECOSTP, it treats. We have a stage 1, 2, 3 underground, which once in 2 years, you remove the sludge. Once in 2 years, you open like this, suppose this is stage 1, 2, 3. One chamber, only you remove once in 2 years and remove the sludge. And it's a fertilizer. Right? That's it. And then the stage 3 is all natural. You plants when they grow, you have to trim the plants.
That's it. You just keep pruning
the gardener can trim the plants. Nothing else to be done. That's it. And we say it's built for generations, nothing to be done. And we have proven to be. This is what we do. This is what we sell. Yeah.
This is very interesting what you're telling us. But can you tell me something about in terms of savings or carbon emissions or all that? Because you talk about whatever, I won't say sludge, whatever comes out, the residue matter can be used as fertilizer. Yeah. So I'm sure people who are utilizing this will have a lot of savings. Could you just talk something about that?
Yeah, I think the key savings is the power and
you're not using any power.
Power. That is a huge savings, right?
I'm still surprised. I mean, because you're saying at the end you can still use it for with a bit of disinfectant. You can use it for flushing.
And I'm not surprised because many people ask the same thing. So when we pitched to Pollution Control Board, one of the challenges we had was PCB. Pollution Control Board said that, no, how does it work? No power, what I show it to us. So we deployed one for KSPCB.
They are using?
Yeah, they're using it. And we choose a place wherein a CPCB, Central Pollution Board, is also there, and KSPCB in Nisarga in Bangalore. We deployed it, and it's a tough project because it's an old building. You have to dig the place and manually digging and deploying it. They said, nice. First of all, no power required, no chemical, no operators, no moving parts. Exactly what you told us in a brochure, it should happen, otherwise we'll kill you. So, right, we deployed it. Okay. Right, we deployed it. So that was a key thing. Okay, otherwise they won't get approval. Otherwise, you may be a builder, but unless...
So it's still functioning?
It's still functioning beautifully. So happy with the thing. No power, no chemical. They hardly spend any money. I think a few thousands they have spent last couple of years. That's it. Right, it's beautiful. So it's like, and they are experts, right? So they took the water, tested it out, and the burping. Right? So that's why they clearly. So definitely, I want to clearly say that the concept is not something. It's not an idea. It's not another startup idea. It actually works. We have shown to customers. Yeah.
Tharun, if this is working, case PCB, why are they not talking about it? I mean, I've approached the case Karnataka State Pollution Control Board so many times. We've spoken about this issue, but no one even talks about this.
Yeah, I know.
I mean, because you have so many apartment complexes coming up, dime a dozen in the city. Yeah. They don't talk about this.
Right. So I take consolation from the allopathy. I was just Googling sometime back. How many people use allopathy? is over 90%. Only 7 to 8% use as per Ayush calculation, Ayurveda, homeopathy. But still 90% is still allopathy. But allopathy works in many cases.
No, it works.
It works, right?
Ayurveda also.
Ayurveda, but in our case, it's not that the 99.9% is SBR, MBBR, the one I showed. Right? That's a prevalent model, right? That's a current paradigm. So now we're trying to break it, right? So it takes some time, and it's not that people are corrupt. Some are corrupt, but most of them is like this. Okay, I'm an MBBS MD doctor. I'll only refer allopathy. I'll not refer a Ayurveda medicine or a homeopathy medicine. So we are in that homeopathy Ayurveda bucket. So we are trying to prove them, sir, this works. Look at KSPCP, look at customers. It actually works, and then slowly shifting them. And most of the decisions are made by consultants. We call MEP consultants, or they're the guys who decide. And they are hardcore on the focus on the MBBR, MBBR. That's where they lived the life, and
true.
Yeah, that's how they are, right?
So basically, they've grown up with that concept.
Grown up with the concept.
This is what it is.
And again, coming from the IT background, I did some deep search on why it is like this. Because they all read one book. It is so surprising. I'll share that book copy. It's a book called Wastewater Engineering by Metcalf and Eddy. It's a big book. That is the single Bible used for all STP companies, because that's so expensive. It used to be 30,000 rupees per book, and now I'm sure it will be cheaper. And those books are kept prominently in every sustainability MEP team's office. That's one book. And that book's all about aerobic bacteria, how it works, and few pages on anaerobic, right? So it's a big book. So we read the book and you come out like a zombie.
So
right?
Basically, you focus on anaerobic, and that is all about aerobic.
And they study this and come out, and maybe the book is so expensive, that's why they don't buy any other books. Because in IT, we read hundreds of books, and there are so many disruptive players which can go through it, right? It may or may not work, but at least there's some option. Here, everybody studies, and they all come like this, and okay, it's not in this book. Okay, this book says, so that's what is another issue what we found. And there's no money in aerobic. Aerobic, where the blower, the research, all the R&D money is going into how to make a better blower, how to make a better this STP, all the big companies.
So they're not thinking out of the box.
Yeah.
And that's what you did.
Right. Yeah, and that's the largest competition we have is Thermax and Exchange. They all do motor-based STPs because that's what customers want. It's called the classic innovation dilemma, because customers want that, right? So I keep producing it, and I can't stop it. I can't go until no, I can't do zero power, zero chemical. It's too disruptive. So that's but we're trying to change.
So for you, it was all about the bacteria. It was about what happened in your gated community. But I'm sure you would have had a huge team along with you to help you along this.
Yeah. From beginning, I knew that I can't do this alone, right? First
it's
of all,
not possible.
It's not possible. It's a huge issue. 99.9% is MBBR. So I had a team, and it's a big problem, nice problem. A lot of people helped us across the world. All helped us. So we had Pankaj who set up the entire company. So he did the entire. He's a finance guy. He set up all the company. He didn't charge any money. He just set it up. Then Atul took over. He ran all the finances for us. We had Prasid who set up all the building processes, like foundation. He built it up. Simar came in. She helped us all the customer acquisition part initially. We had people like Nagabhushan. Nagabhushan, I am Bangalore. He set up the mission for us. Our mission is to reclaim every drop of wastewater naturally. Right, so that coin every single drop of wastewater naturally. So he worked with us, created the mission statement. We had Karthik coming from the purpose. Like, why are we doing this? What is ECOSTP all about? Why are we existing? What's the purpose? What's the why? So there's a science behind it. So he came with all the. So these are experts in this space. Right? They all came together in the stuff. And then we had teams. We have which I call now the scaling team. Right? The scaling team is we have the Lokesh. Lokesh for heading Budweiser. World's largest beer company. He was treating the thing. He joined from there. He was hitting the quality, but business transformation. Actually, guys, join me. What are you doing in Budweiser? Right? So he joined from there, right? Of course, he's missing the barley.
Yeah, I mean, from beer to STP.
It's huge. All of us took a huge salary cut, opportunity cost, because the cost was so big. It's also alluring also, right? So I'm as a 99% is, and everyone has got stories. They are suffering from the STPs, noise, smell. Okay, here is some solution. Ramya joined from Just Dial. She was heading the learning and development Delhi. So she joined us, right? Sunil Oldhand, he joined to set up the community. We need to build a community. So he's a community expert, right? So he joined from community. We have Dr. Praveen, he joined us from the tech side. We had Dr. Nazia joining us. Amar Patel from Times, he joined to set up the sales thing. So they all came in together to put it. And now we have now we have Murali. He was at the HP for 30 plus years. So all those experts came in. And for a cause. And that's what we want to do it. We want people to join us. It's a movement. Don't take it as of course, we are a private limited company. But it's more a movement. We're trying to change the scenario.
Okay. I want to talk about now how many people are utilizing it, and do you find any sort of resistance from, maybe not from individual people, but from builders?
Yeah, definitely the builders are, our segment is, one is the builders, one is the builders like Adarsh Brigade, etc. Then we have factories like Tata Steel, Berger Paints and all, and then school colleges.
But how do you convince them? I mean, that's the first thing, right?
So first it will be the same thing, right? You already have an STP plant, right? Yes or no? You have an STP. If you don't have an STP, then nothing we can do. If you have plant STP, this will definitely be cheaper. This will cost little higher. Capex we cost little higher because a lot of civil work goes in. But that can be offset if you are a builder. Like we're doing a large project for others. They're buying in bulk. Basically cement, steel, labor and sand, right? So they can buy in bulk.
That's it.
Yeah, so they can offset. But apple to apple, we are expensive Capex. But running costs, we are 93% cheaper, way cheaper. Right?
No energy.
No energy thing.
No chemicals.
Yeah. So,
no people.
Yeah, good. The biggest issue we face is, guys, it's too good to be true, right? What's wrong? What's the bad news? Right? I'd rather go with a trusted guy. And when it comes to sewage, let me talk in a risk, right? Man, let me go to the, and decisions are not made in the top. They always put somebody down. And it's not an iPhone. So people don't get into decision making on STP. Left to the somebody in the ops manager, and they take only what was relevant to what they used to it, right? So we convince them slowly, and the way we do this is one is use pollution control board. Say PCB is using it, the regulator is using it. Guys, what more evidence you want? Number two, we make customers speak, because if I go and tell Nolan, 0 power, 0 chemical, and I have this cow on my, why should you believe me? Yeah. So we'll make the customer speak. So our first customer, Suhail Rahman, he was a champion, co-evolved states. He said, guys, he's part of Credit Group. Okay, I did ECOSTP and I made money. I saved so much money, right? So this is Suhail, this is a tribe. Okay, he's a builder. He gets nothing by giving me testimonials. He doesn't have a stake in my company. He's just, he's a do-gooder. He's a leader in the sustainability space, and he said this, right? Okay, then great. So we got some customers. So we have 26 customers now, CEOs, who's talking about us. To give an example, recently we had a Tata Steel, a general manager in a factory in Tada, in Nellore. So a factory has got so many challenges in a day. Factory guy is always, a factory general manager is always in run. Last thing you want to do is to get into the STP business. So that headache is over. He put EcoSTP, is working well. So we took a video. He actually took the STP treated water in a glass. It's clean like a Bisleri water, right? And he's showing this water, wearing the Tata shirt, and say, guys, this is a STP. No power, no chemicals, no operators. I'm happy. And that's a tribe. And that news spread to the other people. That's how we sell.
It's interesting you mentioned industries, because see, now you've been talking about grey water, black water, but there is a difference between what comes out of a normal a building or a house, but what comes out from a factory, the effluent. Yeah. Can this treat effluent?
No. Yeah, good question. Not yet, right? But not yet. But we are working on it.
Okay.
Let me explain this, right? So, like I said, we are more R&D shop. We worked on anaerobic bacteria is what we really were focusing on. So the ETP is a big market, effluent treatment plant, like you said, the factory waste. So we want to have a bacteria which actually cracks that. So we work with the IIT Jammu. So IIT Jammu is a very interesting arrangement. It's a joint IP, joint revenue sharing agreement. It's a very deep connection what we have. And IIT Jammu has got 4-5 EcoSTPs also at the site.
They have that.
They already have that, so they can test out. So what we found, Nolan, is we found a bacteria, discovered a bacteria, a novel bacteria which kills chemicals. We codenamed as PEB, phenol-eating bacteria, right? So when you put in a petri dish, it's an anaerobic bacteria, no power, no chemical, but it actually decomposes all the chemicals in the lab, not in the field yet. So now we're working on it. Now this work showing a lot of good promise. Now the question, before you ask this question, is it tested, right? Is it safe, right? This is a question people ask. If something can kill chemicals, that organism is a beast.
We would not want another Wuhan sort of virus outside.
Exactly. I don't know how everyone says, Tharun, don't create another Wuhan, right? I mean, you are a startup. How can you? So what we do is, let me explain. In fact, I wrote a LinkedIn post on this. How we do the testing, biosafety. So we take this bacteria, we do a metagenomical study, and I'm making it very simple, and then scrap the bacteria in a petri dish. It's not that easy, but I'm just saying. And then you put another bacteria to counter this. We use a bacteria called Rhizobium militota to be specific. So that bacteria, Rhizobium is a very weak bacteria. and we put both the bacteria together, there's a chance that bacteria, rhizobium will die. That means this phenol-eating bacteria is very toxic, is very strong. If it doesn't die, it's kind of safe. It's one way. It's known as a meta-assay test. This is one of the biosafety tests we are doing. One of the tests. I'm making very simple, very complex, but this takes time, right? It takes long time. This is what we call deep tech research. Deep tech is takes time. It won't happen overnight like this because I can't push this.
But we are looking at in the same way using similar bacteria to treat effluents from industries, which is damaging all our lakes.
All the land, right? So now the other part is I'm working on the bacteria now. I'm also doing research on the house for the bacteria, the cow stomach part. I told you, right? The bacteria house, right? So we're building some structures where a bacteria, endemic bacteria, can live much better. Is the way the pipes are done and all. I'm not going details. That we are working along with. We got a grant from Titan. We are forcing that, and it's an R&D grant, and we're working on it. So we're working on a house for a bacteria, and the bacteria itself is coming up. So we hopefully will have something for the ETP market.
I just wanted to know this. Say, suppose I want to set this up in my home. Is EcoSTP okay for a single home or is multiple homes? And do I need to, get you all to come over there in a different city? How does it work?
No, we need at least 8 homes minimum, right? So technically we call KLD, kiloliters per day. We need 5 KLD is a minimum and 1000 KLD or 1 mld is a max. We are talking about decentralization system. So this can't replace a government STP. This is decentralized. So every home, like the rule says every home building, not every home, every building should have an STP. So that nicely fits in. So if you're doing this building, STP goes in the basement, and from basement, all the stage 1, 2, 3 goes to the basement, and then the wetland will be in the top along with the garden, and you get clean water out. But that's a capacity. Home, we don't have it yet. But that's a market. That's a B2C market.
Okay.
That's different.
So you have your team spread across?
No. We are still focused on B2B. Okay. That's as a startup, I can't do everywhere, and it takes some time. So right now we just focus on this market, and that's what we do.
But I understand B2B, but I was also reading where you explain to your customers how to do it. You don't necessarily have to be there. Somewhere in Ladakh, you have done something?
Yeah, right. Yeah. So that's another innovation what we did. One is we have that innovation on the technology, the bacteria and everything. That's an innovation what we have. Second thing what we have is the way we deploy this, the business model innovation, what we call. So we have a software called Flow software. So I told people to help us. So I spoke about Lokesh, the Six Sigma. He's a Six Sigma master black belt. So he sat with another well-wisher called Rishi. Rishi is our digitization partner. Again, all of them are living on what I call love and fresh air model. So he came in with his team, and we made a software to do remote management. So using the Ladakh example, the STP was done in Ladakh using Ladakh material, Ladakh labor, with the technology from Bangalore. So I don't have to. The other model was originally, that's the reason we came to Brigade for incubation, because we thought we'll join with Brigade and then we make the whole thing and send out. But Brigade REAP told us, don't do that, right? But the biggest cost is civil cost, cement, steel, labor and cost, and the builders can buy cheaper. Do the licensing model. Be a Qualcomm. Just focus on the research. Let someone make the cell phone. That's why the mentors are so important.
Yes.
In fact, Brigade REAP is the reason we are here. They really. These are very strategic insights. Boss, don't do this. Do this. Because Ladakh, we do this. So then, once you get direction, you know how to do this. The how part. That we made this software called Flow. With Flow, we control this. So now we do in 26 states in India. 26 states.
26 states.
Yeah. From Bangalore, we do it in Maldives. We do it in Bangladesh. From here.
So you're just sitting over here and everyone's doing it.
Yeah, and wow. I give that tech license. Tech license has got the drawings, there's a bacteria, there's some structures for the bacteria. So certain items are there which you can touch and feel, plus certain things are soft, drawings and all.
But the bacteria, they source it from there itself?
No, only the bacteria. Only bacteria. And there's some of the material also we supply. Certain material, some recycled plastic material will be supplied because we need a house for the bacteria part.
Okay.
So we call a kit. So what is saying, buy the kit from us, you add a concrete, STP is ready. So just buy the kit from us. And so if you can do it in Bangladesh and Maldives, you can do the whole world from here. So that's
sitting on here.
So, that's what we're doing.
Tharun, we're almost to the end of this, but I just want to know something. If you can tell me what's the most surprising thing that people don't know about sewage? Surprising thing is the same thing. Most people don't understand sewage. They don't care about sewage. This is not iPhone, right? So if you're buying a house, first thing you should ask is where is the
sewage treatment system, right? You only ask for what is the bathroom fittings and what is the
or if there's a lake nearby, if there's a park nearby.
Yeah, right?
Lake, mostly lake. I mean, I don't understand how people don't understand that. They say they want lake view, and we're destroying our lakes.
Yeah. In fact, one of our builders, Nagaraj from Ambient Builders, he went out to Radio City for a whole month, saying that when you buy an apartment, ask question like what STP, because that's going to hit you most,
yes.
Right? Not because the running cost is so high, something like 600 rupees per month in a monthly bill is STP. If you have an STP, buy my apartment, it's got EcoSTP, you will save the money. So he went, but he's concept selling, but who cares? This is not something nobody wants. I would like to see what are the bathroom fittings, the carpet area, and that's what my mind switches off. So what we're saying is important. So switch back, look into this is what really matters, right? So.
All right. And maybe lastly, a myth about STPs you would like to bust.
Myth about STPs, first of all, EcoSTP or any nature-based STP works, right? That fundamentally works. It's not oxymoron. People say that, oxymoron, right?
Yes.
Your honest politician, true love, and those kind of things.
Honest politician can be there, but okay.
This actually works, and water can be recycled. We have clients who are using the water for over 1,000 times. Imagine same water used for 1,000 times, right? How is it possible? So flush back, but clean water. We have customers with 1,000 times. We recycle the same water.
No odor, nothing.
No odor, right? We can 1,000 times. And if you take a step back, water is a finite resource. 4.4 billion years before we had water, the same water is recycled back. There's no new water.
It's the same thing.
Same water. You think that is different, but it's the same.
No, it's the same thing.
Same thing. Whatever the dinosaurs pieces what we're drinking now, it's the same thing. Hydraulical circle will come back.
Yes.
So technically nothing wrong with 1,000. But if you say, how will you do 1,000 times? Man, 1,000 times is normal. There's no new water. Anyway, you're doing this, right? So that's a perspective.
All right. Tharun, lovely conversation. I mean, I know what's an STP. I've been there. And I've also now, thanks to you, you've shown me how your STP works. Hopefully people understand, and the KSPCB also understands that it's better to think for the future, change our mindset, and do something that is actually good for the environment. Thank you so much.
Thank you very much, Nolan.